Hello, honors, probability, and stats. We are starting chapter 7 now, and all of chapter 7 is going to deal with normal curves and sampling distributions. 7.1 is going to deal with graphs of normal probability distribution. So here are the things to be able to apply the empirical rules, the 68, the 95, and the 99.7. And then if I give you a mean, let's think about it. If I give you a mean of 18 and a standard deviation of 2, you draw that normal curve. In the middle, you write 18, and then you're going to add 2. You're going to write 20 on that first line to the right, 22 on the second line to the right, 24 on the third line to the right. Going back, the first line to the left, 18 minus 2 is 16, and then the second line to the left, 14. And the last line, the third line to the left, is 14. Or no, we went 18, 16, 14, 12. All right, guys, that is chapter 7.1. You're going to need to know. Number 1, you're going to be able to graph a normal curve and summarize its important properties. Basically, it's addition and subtraction. Second thing is you're going to apply the empirical rule to solve real-world problems. The empirical rule is basically 3 percentages that you're going to have to remember and memorize, and then apply them to different problems. Deviation. So what you see here is a normal probability distribution or a normal probability curve. You can see it is a bell-shaped curve. Now, there are a bunch of properties that you're going to need to know about this particular curve. First of all, smack dead in the middle is the mean, the population mean, which we call mu. The standard deviation, which is denoted by sigma, if you notice to the right, we're going to add one of the sigmas, one standard deviation. Here you're adding another one, so you're adding a total of 2. And here you're adding another one, so now you have a total of 3. No more than 3 standard deviations. In the left direction, getting smaller, you're going to subtract the standard deviation once, you're going to subtract it twice, and you're going to subtract it 3 times. A couple other vocabulary type things are these 2 inflection points. Basically what an inflection point is, it first of all is at the first standard deviation. This is considered 1 standard deviation above the mean, and this is considered 1 standard deviation below the mean. And this inflection point, this guy right here and this guy right here, which is at that first deviation, and where it goes up and meets the graph itself, it changes from, if you see this one has an upward cup, see how this is an upward cup? And then this is a downward cup. This is a downward cup. So therefore, those 2 inflection points is where the graph changes from an upward cup to a downward cup. Okay, so all of this is just pure memorization for you. And a mean when given, labeling the normal curve. So what are your important properties of a normal curve? Number 1, the curve is bell-shaped with the highest point over the mean, which is in the middle. The second thing, the curve is symmetrical about the vertical line through mu. So everything that goes to the right is the same as the left. Number 3, the curve approaches the horizontal axis but never touches it or crosses it. Number 4, the inflection points between cupping upwards and downwards occurs at 1 standard deviation above and 1 standard deviation below. And the last is the area under the entire curve is 1. If you're dealing with percentages, it would be 100%. Now, let's take a standard normal curve, which I'm going to draw right here for you. Try to draw as well as you can. Okay. As soon as you draw the standard normal curve, you're going to put this line in right here. That is our mu. That is our mean. The empirical rule for the distribution that is symmetrical and bell-shaped, these are your 3 memorizations. Approximately 68% of the data lies within 1 standard deviation on either side of the mean. So therefore, in that previous picture, remember they had this down? This is mu plus the sigma. This is mu minus the sigma. Let me change this to red. And there is 68% of the data would be located between those 2 values. Continuing, if I make a line here and a line here, this is mu minus 2 of the standard deviations. This is mu plus 2 of the standard deviations. And what this is saying is 95% of the data is within 2 of the standard deviations. So from this line right here to this line right there, 95% of the data is located between those 2 values. And lastly, way over here with a flick, way over here with a flick, this is considered to be mu minus 3 standards, mu plus 3 standards, and that from here to here, 99.7% of the data will be located between those 2 values. All right. Now they use 99.7 almost all, but it's not 100%. Okay. So those are your empirical rule percentages that you need to memorize. Curve. So in this little drawing, they kind of broke it down just into other numbers for you. Okay. You can see where the 68% comes in. But notice the reason they're doing this is this total is 68%. But since it's symmetrical, notice they broke it down into 34 and 34 respectively. You should know that. 95%. Well, if the distance from here to here is 95, well then from here to here would be half of 95, which would be 47.5. And if you subtract that 34, you get 13.5. That's where the little green 13.5 comes in, okay? And you can continue on looking at each of these particular values, but you want to definitely just take a look and understand each of those particular percentages. Now, if you think about it, if 99.7% of the data is located within this guy right here and this guy right here, well, you got these two little edges on here and here. Well, if you think about it, there's still 0.3% left over. So that little piece at the end is 0.15%, and this little piece at the end is 0.15% as well. Okay, so all we did in this particular slide is we broke down the empirical percentages of 68, 95, and 99.7, and just kind of made them a little bit smaller, different things that you need to know. Or 2. Notice this guy right here. This is the same shaded in region. It's part of the 68%, and we can hopefully plainly see that the answer is, that one piece little here is 13 point. The edge is right, oops, what did I just do? 34 deals with the, so let's take a look at an example. This is the empirical rule, and we'll teach you how to draw and label a normal curve. So you're going to draw a normal curve. You're going to slip in a middle line, and then you're going to go here and here symmetrical. You're going to go here and here symmetrical, and finally over here and over here symmetrical. It says, the playing life of Sunshine Radio is normally distributed with a mean of 600 and a standard of 100. Okay, units are in hours. Okay, their ultimate question is, what is the probability that a radio selected at random will last between 600 to 700 hours? Well, I'm going to first show you how to label. The mean is 600. The standard deviation, notice you have to add it 3 times to the right. So add 100 to 600, you get 700, and then 800, and then add it a third time, 900. Subtract it, you'll get 500, and 400, and 300. So these numbers down here, ladies and gentlemen, are not very hard. All you're going to do is take the mean that is given to you, and you're going to add this, the sigma, the standard deviation, 3 times, and you're going to subtract it 3 times. Now let's take a look at our question. The question says, what is the probability, remember probabilities are like percentages, the empirical rule, between 600 and 700. So really we're looking for this shaded in region right here. Oh, wait a second, let's go back a percent. So because of the empirical rule, this percentage is 34%, therefore the probability would be 0.34. Done. Okay, so you're going to see in chapter 1 all different questions that deal with the empirical. All right, so let me add another one. What if I said something like this? What is the probability that a radio selected at random will be between 400, or I should say, will last between 400 and 800 hours? 400 to 800. Remember, this is 2 standard deviations below. This is 2 above. Remember, that was the 95%. So therefore, the answer to that question I made up is 0.95. Okay, so all of them will deal with that same particular value, okay, or the same values of the empirical rules. Okay, I want to do a couple more, and this will finish up this particular lesson. So using this same scenario, I just wanted to erase a little bit. What if I said, we got to start with what's the probability that a radio selected at random, and this time I'm going to say it lasts between 500 hours and 800 hours. 500 and 800. So you figure out where 500 is, which is here. You figure out where 800, which is right here. Using empirical, you know that this is 34. You know that this is 34. And if you can't remember, 13.5. Okay. So basically you add them all together, and that will give you the percentage in between. So we got what, 68 and 13.5. So 0.815. So the probability is 0.815 if you select a radio at random that the battery will last between 500 and 800 hours. And then one more to finish everything up. What if we select, what's the probability of selecting at random that will last more than 900 hours? Well, if this is 900, more is to the right of it. And remember, this was the 0.15%. So therefore, if I'm dealing with a probability, 0.0015. Okay? So ladies and gentlemen, that is chapter 7.1.